Again, for all you guys that are just tuning in online, we're talking about special parallelograms today. Special parallelograms is what we're talking about. So we just talked about the 7 properties of a parallelogram, which are, I just want to read them in order, 4 sides and 4 angles. The sum of their interior angles is 360 degrees. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And finally, the 7th one is the diagonals bisect each other. All of those 7 properties do exist for each of the 3 shapes we're going to talk about today. We're talking about rhombuses, or rhombi is the correct way of saying plural, rectangles, and squares today. So we're just going to jump right into this. We're not going to do the little setup and everything else just because I think it's going to take a little while. So I'm going to jump right to the answers here, I guess. It says, a rhombus, the diagonals of a rhombus, well, they're perpendicular. And the symbol for perpendicular looks like this. Looks like an upside down T. So they're perpendicular. And, well, guess what? They also bisect each other. They bisect each other. Okay? So the bisect each other is like, well, duh, because we already know that because that's a property of a parallelogram. The diagonals bisect each other. But I just want to kind of put it in there so that we knew what was going on. Also, the rhombus, the angles conjecture, this is kind of a strange one, but the diagonals, and we kind of have to add a word in here, the diagonals of a rhombus, they bisect, and we have to kind of add this, maybe add this over here, to the opposite angles of a rhombus. Opposite angles of a rhombus. Okay? So, for instance, in this shape here, what else do you know about a rhombus, by the way? What's special about it? It is a parallelogram. It looks like a diamond. We say the word rhombus. Yeah, I agree. What do we know about the side lengths?
Only one pair.
They're all the same, right? All 4 of these are the same. So that's one fact that we know about it. That's not actually listed up here because it's we already talked about this here. These are all right angles. Yeah, that's what this perpendicular thing means here. That all of these are going to be right angles. So that's supposed to be a little box there. Okay. We also know that the diagonals bisect the opposite angles. So what that means is that this angle is the same as this angle here. Okay? Well, since it's a parallelogram, isn't this big angle A the same as this big angle C? Aren't those opposite angles in a parallelogram?
Yes.
And aren't D and B, aren't those opposite angles in the parallelogram?
Yes.
If we knew what A was, can we figure out what B is? Yeah, because those are consecutive angles, so they're going to be supplementary. So really all they need to tell you is they basically need to tell you like one of these is like, I don't know, like 40 degrees or something like that. And we know this other one here is like 40. And then we know, hey, since that's 90, this has to be 50. That has to be 50. This has to be 40. This has to be 40. This has to be 50. This has to be 50. Like it all just falls into place. Once you know one of these small angles, you can figure the rest of them out. Okay? And part of that is using the triangle sum theorem, basically that these form 4 triangles here, and they would all add up to 360. Okay? So there's a lot of things that go on with rhombi that are kind of strange. Okay? So once you know a little information, a lot of it goes like a long way. So for instance, this says that AE is 12, so this distance right here is 12. So I'm going to label that on my picture. I always think it's a good habit for you guys to get into, to label your pictures with whatever information they tell you. Because DB is 30, so that's this entire thing here is 30. Okay? DAB, that's this top part here. Oh, I was just kind of guessing what it was earlier. There's 100 degrees right there, the whole angle. And then angle ABD is 35. I think that's really good to add up. Okay. Let's pretend that's correct. It doesn't really make sense to me, but that's okay. Okay? How long is AC? How long is this entire diagonal then? If we know half of it's 12, how much is the whole thing? 24. If we know the whole diagonal over here is 30, how long is half of it? 15. That's pretty good. Angle DEC. So D to E to C. Well, diagonals are perpendicular, so what would that have to be? 90 degrees. Angle ABC. So from here, like this, if half of it's 35, what's the whole thing going to be? 70, okay. Seems like we're just either dividing by 2 or multiplying by 2 for a lot of these answers. Angle CDB. So let me just draw some of the different colors. It starts at C, it goes to D, and goes over here to B. Well, how is that related to any of these other angles that are up here? Wow, that's good. These two are parallel lines, and here's your transversal that cuts through them. So if this is 35, what does this have to be?
35.
Also has to be 35. And that's some of the things that people kind of come in the morning and ask me about. They ask me, well, how do you know about these angles? How do you know about these two? Well, a lot of it has to do with, well, they are parallel lines. So you need to start applying the alternate interior, alternate exterior, same side interior, same side exterior. Which, Nicole, if you want to talk about that later, we can definitely chat about that to get that formalized. Okay. And then angle is DCA. So from D to C and then up to A. What would this small angle right here have to be? Well, if we know this is 90 and we know this is 35, I would think it'd be 50 because this one up here is 50. I think they messed up the problem when they actually wrote it because 90 plus 35 would mean this has to be, in order to add up to 180, I'd say it has to be a different number. Should we say it's 50? Let's say it's 50. Okay. But if you use the triangle sum theorem, I don't think it's going to add up to the right number. I think it should be.
Yeah, I think it's 35.
Yeah, I think it should be 65, 55.
65.
Yeah, I'd say either one of those numbers is fine because they messed this up. This is probably not right. Hi. You're all done? You want to do the other one? Sure. All right. All right. Flip to the next page, or the next part of it. Maybe it's still on the same page for you guys. It's a different page for me. We look at this. Now all of a sudden they put variables into it. Not a huge deal, but here's some variables. It says AE. This part right here is just, maybe I'll draw this. 2x plus 2. dv, the entire thing here. Draw a little arrow for that guy. That's 4x minus 6. And angle DAB, so this whole angle right here, that's 127. This is really sloppy. Okay? So if we know that part of this is 3x plus 2, how do we figure out what all of AC is? What do we have to do? We multiply by 2? What would that look like here?
Well, I was going to say, like, it says off for x.
Well, we'll do that later.
Okay.
We're going to get there soon. We're going to do these in order, so let's do this part first. If it's 3x plus 2, and we have to multiply by 2, what's twice 3x? We know what AE is. We wanted to do the full thing, AC. So, since the diagonals bisect each other, this length is the same as this. So we just would multiply by 2 to get the whole thing. Yes?
And it would be 6x plus 4.
Yes, this would just be 6x plus 4. We had 3x plus 2. We're just going to multiply that by 2 because it's half of the whole distance. Okay? If DE, I'm sorry, if DB, this entire length here is 4x minus 6, then what's half of that going to be?
2x.
That's going to be 2x minus 3, right? So half of 4x is 2x. Half of minus 6 is minus 3. Okay? Measure of angle DEC. Where is DEC? D to E to C. Well, what's that against? That's 90 degrees. You start at angle D, you move to E, you move down to C. That's going to be a 90-degree angle. What about the measure of angle ABC? Yeah, if we know this angle up here is 127, how is this angle and this angle, how are these consecutive angles related? They're supplementary. So you say 127 subtracted from 180. That's going to equal, what did you say, 53? 53 degrees. Okay. Those two are supplementary angles. They're consecutive angles, so they're supplementary. Okay, now it says, hey, solve for x if AC equals 22. So we know that AC equals 6x plus 4. That's what it says right here. Okay, and now it tells us that it also equals 22. So now we just have an algebraic expression that we're solving for. So I'm using this information right here that says AC equals 6x plus 4. It then tells me that AC is also 22, so I'm just going to set those two equal to each other. Tyler Cox, how do I solve for x? Subtract 4 from both sides. What do I get? 18 equals 6x. And what does x equal? X equals 3x. Bravo, there it is. Okay, so we'll see several problems that are similar to that, where they're giving you expressions, and sometimes your answers are going to be expressions. This is a little strange, but it does work. Does anyone have any questions about a rhombus? Okay. I'm just going to give you a little heads up on this. We did take a quiz today. We have a guest speaker Monday. We have no school Tuesday. When you come back Wednesday, though, we could probably have another quiz over some of these properties. Okay? And we're going to learn a lot of extra properties today. So maybe I'll do parallelogram again. Maybe we'll ask the properties of a rhombus. So the properties of a rhombus would be the 7 we already talked about, as well as this guy here, and maybe that all 4 sides are congruent would be another one. That'd be 10 properties of a rhombus. Okay? So maybe keep that in mind. Okay? Let's talk about a rectangle. Okay? Rectangle. Okay? We already know opposite angles are congruent, opposite sides are congruent, consecutive sides are supplementary. We know that basically the other thing about a rectangle, the 4 interior angles are congruent as well. That's kind of the new thing that we learned. Basically, all of those are 90-degree angles. 4 interior angles are congruent. But the diagonals, well, are the diagonals perpendicular? No. Do the diagonals bisect each other? Yeah. What else do you think you could say about the diagonals? They're congruent. Yeah, they form an X, that's for sure, Tyler. But they are congruent. And, well, again, they bisect each other. I keep writing this on here because a lot of people end up forgetting this one rule about the diagonals bisecting each other. They just kind of forget. So really what this is saying is that the entire length of AC is the exact same length as DB. And this length here is the same as this length, as this length, and this length. Okay? All 4 of those are exactly the same length. Okay? That's really what it's saying there. Okay? So let's explore this. Tyler Mancuso, if we know AE is 12,
yeah.
What else up here is 12? Okay. What? AEC is 180 degrees. You mean just EC? Yeah, EC is 12. What else is 12? EE, and then also EB is also 12. Sounds good to me. Let's see, angle AED, this is really hard for me to say, is 70 degrees. Tyler Mancuso, what else is 70 degrees? DEC, this is also 70 degrees. Why? Vertical angles, you see it actually forms a B for vertical angles. Nice job. Nicole, what would this angle right here be? Angle BEC. Doesn't tell us. Well, if this, we know one of these, this is the guy right here, 70. So how are these two related if they're right next to each other on a straight line? It's not going to be 70. This one, different sizes to me. You want Brett to say it? Brett?
Actually, wouldn't A or I don't think it's. I think it's.
You think I'm right in the wrong spot?
Yeah.
Okay.
I think 70's on the side.
You think I'm saying this is 70?
Yeah.
So what's this going to be?
180.
Not 70? Okay. I'm sorry, I think I messed it up then. Okay. Why is it 110?
Because 180 minus 70 is.
Yeah. You basically say, hey, it's 180 minus 70 is going to give you the 110. Okay. What else is we looking at? That should be pretty close. We could probably figure the rest of these out. Okay. So how long is AC? It's 12. How long is DB? 24, right? Because the whole thing. How long is DB? It's 24. It's the whole thing. DEC, so from D to E and then down to C, how big is that? That's the 110 degrees. How big is ABC? So from A, B, and then down to C, 90 degrees. That deals with this part right here. Measure of angle CDB. This is so C to D to B. I guess it's going to be 35 because I think what we do is we say these two are X because they're going to be the same amount. So we say like X plus 110 has to equal 180 degrees. So this triangle
They give it to you too.
is 100. Gives it to you?
Oh, yeah.
Oh, I do that right there. So that's 35. What's this last one then? That's also 35. Man, I'm getting really tired of doing this. Is anyone else getting kind of exhausted doing this? Yeah. Man, wait till you see your homework. Okay, last thing. Squares. Now, what do you know about a square? Okay, it's basically, it's the combination, it's a rhombus,
Rectangle.
and it's a rectangle. And what else is it? Yeah, it's also a parallelogram. And a parallelogram, remember, is also a quadrilateral. So it basically encompasses all those things. I think there's actually 13 total properties that a square has. Okay? So when we talk about its diagonals, all it's doing is we're just basically combining the concepts that we had before for a square. So the diagonals of a square, well, they're going to be congruent. Okay? The diagonals of a square, well, they're also going to be perpendicular. Okay? The diagonals of a square, what they do is they bisect each other. Bisect each other. And lastly, diagonals of a square, they also bisect opposite angles. That's a lot of information about the diagonals of a square. They're congruent, they're perpendicular, they bisect each other, they also bisect opposite angles. So here's what that means. Let's just pretend, hey, this is 90 degrees. Is it 90 degrees?
Yes.
Okay. So how big is this angle right here? Just that little part there.
45.
That's going to be 45. This is going to be 45. That's 45. That's 45. You can see that's 45, 45, 45, 45. Okay. Hey, what's this in here?
Oh,
How big is that going to be?
90.
Has to be 90 degrees. That one's 90, that one's 90, that one's 90. Okay? We also know that if we know this length, it's also the same as this and this and this. We also know that if we know this length here, it's the same as this one, and this one. Holy smokes, look at all the information up there. Okay? And that's for every single square. I haven't even marked anything on there. Okay? So let's mark this really quickly. I know it's Friday. It feels like a Friday to me as well. AC is 10. So this entire length here is 10. Okay, so what do I know about these two small pieces? That's 5, that's 5, that's 5, and that's 5, right? Okay, if it says that DE, where in the world is DE? Oh, DE must be this. Let me do this in color. It says DE, this part here, is then 3x minus 2. Okay? Ty Richardson, what's AE?
AE. 5.
Okay. How long is DB? How long, what's the measure of angle of DEC? DEC?
45.
DEC is 90. As you go, you start at D, you're going up to E, and you're going out to C, 90 degrees. What's the measure of angle ABC? 90 as well. What about the measure of angle CDB? 45. Are you sure? There you go. This is 90 degrees. You said, let's see, CDB. So from C to D and then over to B. That's this angle right here. 45. DCA. DC to A. That's also going to be 45. And here's the last thing. We use this concept here. How do I set this up, Ty? 3x minus 2 equals what? How long is DE? 5. I agree. Each of those small pieces in here are 5. That's what we figured out when it told us our piece there. Before you finish this, Sierra, what's the question?
I don't get how angle C, which is kind of small, is equal to 90 degrees.
DEC. Because the diagonals are perpendicular. It's this angle right here.
And then the other one is just half big, 45.
Yeah. I don't think it looks bigger at all.
He's talking about this more space.
I think that's a 90-degree angle. I think these two are 45. I think that's more legitimate. And all I did is I just rotated it. So that's the top right there. That's 90. And these two down here are 45. And that's right. Ty Richardson, what do I do?
You got 2 from each side.
Okay. What does that give us?
You add two?
You add 2. Oh, I meant add 2.
No, adding two is for help now. What do you want to do now?
Say you want to start over.
You want to start over?
Okay. So I just erase this whole page.
Yeah, it was like all apart. And move one.
What do you want to do now? Yeah. Ah, okay. We had two. Ah. 3x equals 7. Okay. What does that mean?
That is not 7. That is not 7.
And I'm not frustrated.
Okay. Use your calculator.
It's a smiley face. It's a smiley face. 2.3.
2.3 to the nearest 10. Sounds good to me. Thank you for helping. Too bad Ty Richardson couldn't get his calculator out of his bag, even though we stalled for him so he could do it.
This is on the internet, Ty.
It's ridiculous. Okay, ladies and gentlemen, your assignment is going to look very similar to this. I do want you to be ready for a quiz coming up on Wednesday. I want you to be ready. Know these 7 properties. Know the additional properties that we studied today. If you need some help, you can come and talk to me Monday before after school. You can come talk to me Wednesday before school as well. Okay?